this table with all these different categories, and we got together all the major representatives from the agencies funded by the U.S. government to do tropical cyclone research. This includes NOAA, of which I'm a part, the Navy, NASA, National Science Foundation. Those are the four primary organizations that do tropical cyclone research. So the representatives came and we all were involved in developing this table. And then we went back to our respective agencies and we said, well, let's go back and look for 1 year, one fiscal year, at all the activity, all the research activities that are going on at our agencies. And let's map them onto whatever these categories are to see what type of areas the different agencies are addressing as far as these research needs. So this is what we came up with. This is actually, I think, the first time this has ever happened in the U.S. that multiple agencies have come together to really look at where we are in terms of tropical cyclone research and where the resources are going. So just to summarize, basically, in terms of man years, or the number of people and the amount of time being dedicated toward tropical cyclone research in general is 228 man years. And so this shows you the distribution of man years among the four primary agencies, NOAA, Navy, NASA, and NSF, that's occurring. So as you can see here, the blue is the NOAA agency, and that is the agency doing the most in terms of total man years toward tropical cyclone research. Where I work, HRD, so these are the specific components of NOAA. I work at the Hurricane Research Division. You can see within NOAA, we actually do the most in terms of man years within NOAA. But the NASA and the Navy and the NSF also do significant amounts of research in terms of man years. GFDF should be in there, yeah. Something personal, I think. There was some debate on whether they would fall under the hurricane or more climate research, things like that. So, okay. In terms of the amount of money going toward research, again, you can see that NOAA and the Navy and NASA and NSF all contribute significant amounts toward tropical cyclone research, with, again, NOAA contributing the most. But again, it's a snapshot of where we are at that time and you know, where the resources are going. Okay. So then what we did was we, in sort of a bar chart format, we saw where these activities were mapped across that research table that I showed you a couple slides ago. And so these first categories here are the general research that I talked about: intensity, structure, track, genesis, QPF, rainfall and surge, model development and observations. So you can see that the different agencies are represented by the different colors here. But what you can see is that a lot of the research is going toward intensity and structure, which, as I'll show you in a minute, maps on pretty well with some of the top priorities from the operational community. However, there's also a significant amount of research going toward genesis. However, most of that research is not happening within NOAA, it's happening within NASA and the Navy. Also, a significant amount of research is going overall toward model development, including a significant component from NOAA. And finally, observations. There's another spike in terms of research for observations, of which NOAA is by far the dominant contributor. After all, we conduct hurricane field programs every summer, and so that's a significant contribution toward our observational efforts. Okay, so these circles are just showing where the dominant NOAA activities are: intensity and structure, basic research, model development, and observations. Okay, so now going back to the operational priorities. Okay, so this is that table of 14 priorities where rapid intensification and intensity change was the top priority, observations was up there, guidance on guidance, all those things. Now what we've done is we've linked the research needs from that table, that big table of research activities that I showed you. We mapped each of those activities onto the operational needs. So for example, to look at intensity change, you need to conduct research in these various categories: A1, which was intensity and structure; B1, which is data assimilation; you know, all the sort of model development topics, as well as basic research. So the reason we did this was then we could go in and go back to those tables that the various agency representatives constructed to see where the research activities within the various agencies were mapping onto the operational needs. And what we found was, so now what I'm showing you here are man years, so sort of the amount of effort going into a specific operational need. So this axis is showing you the 14 needs from the operational community, with intensity change being the top priority, observations, guidance on guidance, all the way down to genesis, precipitation, and the activities. So the amount of research going into that specific operational need is shown based on the bar. So what you can see is that the dominant contributions in terms of research activities are going toward addressing intensity change and size and structure, actually. So now what I'm showing here is, again, the priorities from the National Hurricane Center, which is responsible mostly for the Atlantic and the Eastern Pacific as well. But most of the research is going toward intensity structure, with a sizable research component also going toward genesis. So in some ways this looks encouraging, because some of the most significant contributions from the research community are going toward the top two priorities. However, on the flip side of that is that there are some significant efforts going toward things that really aren't of the highest priority to the National Hurricane Center. So that's something that we need to address. Also, we need to consider the fact that there are some efforts that really are not that well developed, and despite the fact that they have a pretty significant priority from the Hurricane Center. For example, the statistical aids, this guidance on guidance. That's a clear deficiency, I would say, in the research community as far as what we're addressing for the operational community. So that's where the HFIP comes in. The HFIP is intended to come in, the HFIP is intended to come in and augment the resources that would be necessary to conduct the research for these various types of activities. So especially in terms of the guidance on guidance, I think that's something that the Hurricane Center would really value. So hopefully that's something that the HFIP can do. So in summary, for this part of my talk at least, in general, our current research is aligned with the operational priorities in terms of the #1 priority, intensity change. 35% of the research is directed toward both intensity and structure changes. However, there is little emphasis on guidance, and I didn't mention forecaster aids. One of the things that we need to do, though, is to conduct an analysis to determine what's the appropriate research level. Just because we have a bar here, okay, so that's 4 man-years, but how do we know what the sufficient amount is? Do we need 5 man-years? Do we need 25 man-years? So we need to have some sort of way of determining what the actual appropriate level is to know whether or not it's a real deficiency. So that's one thing we need to do. And then, of course, we also need to construct perform regular updates of the database to relate our research efforts toward achieving these strategic objectives. I've just shown you a single year, but we need to do this every year or every 3 years just to see how the different allocation of resources are evolving over time to hopefully better address these operational priorities. So one of the activities that we're doing as part of the HFIP is to construct or design, I think, what I'm calling a forecasting system of the future. And the hope is that this will provide a path for improving our intensity forecasts. The 3 primary ways for doing this is by improving the models, numerical models being used, improving our observations, and improving our understanding. I think those are the 3 key components that are necessary before we can really experience improved forecasts. So in terms of improving models, of course, we need to increase our computing power, as well as running, one aspect would be running higher resolution models, but obviously, of course, there's different approaches like Nakazawa-san talked about, whether it's ensemble-based forecasting or deterministic forecasting. Improved observations include an improved use of existing as well as planned observational systems and our modeling systems, as well as new observations and new platforms. And finally, improved understanding involving a better understanding of the multi-scale processes that are so important, especially in intensity change. Upscale, downscale interactions, those types of processes that we need to better understand. Forecast techniques to better understand and reduce and communicate our uncertainty in our forecast. And finally, the development of theories, which can be tested by the by the models as well as the observations. So just a quick summary, improved models would involve, for example, global models. One example at NOAA of a model that's being run at Esriel is the FIM model that's been developed at Esriel with help from